Good morning. We will start with chapter number system session 2. So in our previous session we understood what is different types of numbers. We understood how to insert few other rational numbers in between two rational numbers given by two different methods, that is by arithmetic mean method and by generally by equalizing the denominator method. Then we understood how to plot the irrational numbers on number line. Of course, root 4 answer is 2, that's a rational number. So how to plot this on the number line. So in today's session, before I start with an exercise, I want you all to tell few things. For example, if I give you certain set of numbers, say 2 by 5 and 10 by 2, 1 by 3 and 22 by 7. Okay. Now I'll start dividing these numbers. How? By usual norm division method. So 2 by 5, so 5 here, 2 here. So I cannot divide it further. So I'll take a 0, a decimal and a 0 here. So 5 4s are 20, remainder is 0. In the second case, it is directly divisible. So 2 5s are 10, answer is 0. Now let us check with this here. See, 2 by 5 is not easily divisible, but we took decimal and we made the division possible so that we get the remainder 0. 1 by 3 when you start, so 0 I take here, 0.0. 3 3s are 9. I again get 1 remainder, so I can take 1 more 0. 3 3s are 9. Again 1. So again 1 more 0. 3 3s are 9. So 1. So this continues, correct? It is recurring. It goes on and on. That means it is non-terminating. I'll come to that point. Last number, what is this? 22 by 7. It is pi value. We all know that. 22. 7 3s is 21. So remainder 1, 0. Point I'll take 0 because further I want to divide this. 7 1s are 7, remainder 3, so 0. 7 4s are 28, remainder 2, 0. 7 2s are 14, remainder 6, 0. 7 8s are 56, 4, 0. Then 7 5s are 35, so remainder 5. I will go on dividing this. This will go on adding up and quotient will go on coming the same different set of numbers. Okay. Few examples I have just given. So let us now bifurcate them. So here I consider that as a terminating. Now see, this is of course terminating because we got 0. But here we forcefully made it terminating by adding a decimal. So this is also anyhow terminating only. So all terminating are rational numbers. We will write down all terminating will belong to rational numbers. That means all terminating decimals are rational numbers. We can rewrite them in the form of p by q. Keep that in your mind. Look at this. What about this? Is it terminating? What will be the answer for that? 0.3 dash. What is this dash? That is a bar. That bar indicates that it is recurring. Recurring in the sense, what type of recurring it is? There are two types of recurring, children. Now I have not given example, but when we divide, we get number like this 0.33333. Same one pattern will continue. So we'll write that as 0.3 bar. Or we will get a pattern, say 0.125, 125, 125. When you go on dividing, you get this pattern. That means this can be written as 0.125 bar. Okay, that bar indicates that number 125 is recurring. Sometimes we say that as a periodic recurring. Why periodic? 125. After this period, again 125. After this period, again 125. This is recurring. This is periodically recurring. recurring. After every period it is recurring. After every intervals of time it is recurring. This is non-recurring. I'm sorry, it is recurring. Non-recurring are these. So this is recurring. Okay, one thing now what we assume and analyze from this is rational. Rational number is denoted by Q, no? Okay, this is rational. This is rational. These which are recurring, which has unknown number, it goes recurring again and again. There is no number which is repeating properly. That is irrational. What about such numbers where we get recurring but periodic? That is, a number only recurs. There are no different set of numbers. For example, 0.3. A number which is periodically recurring. See, this is recurring. This is periodically recurring. So, these will come under rational. Because all these numbers, that is periodically recurring and terminating, can be represented in the form of P by Q, wherein this recurring number cannot be represented in the form of P by Q. Now you can ask me, for example, 0.4, if I have to represent this in the form of P by Q, how do I do? 4 by 10. 2 2s are 2 5s are. I got the original one answer here. 0.333 recurring. How do I represent? Is this 3 by 10? No, it is not 3 by 10. There is a particular method how we represent this 0.3 bar or 0.12 bar in the rational number, right? That is what we study here in this exercise. But did you get this whole thing like what is recurring? If recurring, what type of recurring? Periodic recurring and only recurring. So terminating decimals, recurring but periodic decimals are all rational numbers. They can be expressed in the form of P by Q. Only recurring are irrational numbers. Now there is nothing that you have to write down here what I have explained in your book or something. But for your understanding, if you want to make some points on what I have told, make a note of something, that is up to you. Otherwise, there is nothing what you have to write what I have taught this part. For your understanding, you want to make note or points on this thing what I have explained, you can always do. So quickly, we'll move on to the next exercise. What they have asked is, write the following decimal form and say what kind of decimal expansion each has. Now they have not asked us whether it is rational or irrational. They have only asked us divide it and see what type of decimal it has. But now you know the types of decimal: terminating decimal, recurring but periodic decimal, and recurring decimal, right? Let's see what answers we get here. I'll be marking some homework because it is simple division. Now you all know what to give conclusion when what type of decimal occurs. So only one or two simple things I'll do. Remaining I'll mark for homework. So first one in that 36 by 100. Now 36 by 100, do not start to 18s are, 250s are, no. Directly you can say this as 0.36. Anything divided by 100 you need not show the division process. Shift the decimal. You know this which we have learned in fractions in lower classes, where we have to convert this fraction into decimal. Shift the number of zeros for the numerator. Yes, what type of decimal it is? Term they have asked. And say what type of decimal expansion it has. It is a terminating decimal. Okay, terminating decimal. Okay, so we'll start with the next one. So 1 by 11. So 11 and 1. So always continue. Always choose the proper dividend and divisor. So numerator is always the dividend and a denominator is always the divisor. Okay. Since we cannot do this division process here, one second. Okay. Since we cannot proceed with this division process here, first of all, then we have to take a decimal, that is with point, and I can take 1 0. With 1 0 also I cannot divide it further. So I want one more 0. So one extra 0 if I want to add, there should be one more 0 here also. So 100. Yes. Now I can divide. 11 9s are 99. Remainder 1. Again with 1 I can take 1 0 because already decimal is taken. But with 1 0 I cannot do anything. I want one more 0. So one more 0. 11 9s are 99. Again remainder is 1. I can take 1 0. Another 0 if I want. 0 0. So 11 9s are 99. Again remainder 1. So this is continuing the same thing. The same number will continue. What number is continuing here? 0909. So 0909 is continuing here. So what we will write here is 1 by 11 is equal to 0.09 bar. Because 090909 is recurring always. Not terminating, sorry. I think I put terminating by mistake. Recurring. What type of recurring is this? This is periodic recurring. Why? Because these numbers are recurring periodically. That means here, this was rational. What about this? This also is rational. But they haven't asked here rational or irrational. So we will write here is recurring decimal you can write, or periodic recurring decimal also you can write. Usually, the word periodic is not used anywhere in your book also. In few of the reference books, sometimes they use it. So, periodic recurring. And I can use one more word, non-terminating. One thing you remember, all recurring decimal, recurring or periodic recurring are always non-terminating. So now did you understand what to do? Okay. So I think 2 sums what I have done. Remaining I will be giving you all for homework. This is what all you have to do. Now see here, third one they have given a mixed fraction. 4 1 by 8 can be written as 8 4s are 32. 32 plus 1, 33 by 8. You need to divide. Okay. So homework. I will not be giving you any more homeworks. I think yes, there will be. No, I will not be giving you any more homework in this chapter, in this exercise. Sorry. So first one, in first week, I have done first 2. So you will be doing third one, fourth one, fifth one, and sixth one for homework. You have to follow the same thing how I have written, then give the conclusion for your answer. Okay. So I'll erase what I have done. We'll quickly move on to the second one. All the sums given in this exercise are almost all where we have to perform long division method only to do it. Okay. Second one, you know that 1 by 7 solution 1 by 7 is equal to 0.142857 bar. Be very careful in writing that bar. If it is on complete number, then you have to use all the numbers, not just 1 or 2 numbers you do and say it is a bar and leave it off. You know that 1 by 7 is 0.142857 bar. Can you predict what is the decimal expansion of 2 by 7? 3 by 7, 4 by 7, 5 by 7 and 6 by 7. That means we need to assume or predict the decimal expansion of these many numbers without actually doing any long division, just by looking at this 1 by 7 and what they have given. If so, how? How can we predict it? They have given us a hint. what they have told here is divide 1 by 7 in the long division method where you get these answers and observe each step carefully. Let's do and try that. Let's see what we will get. So this is 1 by 7. So I take one decimal here. 7 ones are 7. Remainder 3. 7 fours are 28. Remainder 2. 7 twos are 14. Remainder 6. 7 eights are 56. Remainder 4. 7 fives are 35. Remainder 5. 7 sevens are 49. Remainder 1. Again, if I take 0 and do here, I'll again begin from the first one. Correct? Let me just show you. See here. Again, remainder 0. So 7 ones are 7. Remainder 3. 7 fours are 28. That means I'm again repeating 1, 4, 2, 8, 5, 7. Right? So we will have to stop till here. That is why they have given us. So which is nothing but it is a bar. Okay. With this, how do we assume with this now? Now see here, we have done this division process. Second number is 2 divided by 7. Now 2 divided by 7 means after decimal we will make this as 0. That will come as 20 as the first number. I'll just show you the first number so that you can predict the next one very easily. So this is 2 and 7. I'll make it 20. So I have to start with 7 twos are 14. From where I am starting? 7 twos are 14. From here I am starting. After 7 twos are 14, then 7 eights are, 7 fives are, 7 sevens are, 7 ones are, and 7 fours are. Right? What will be the answer? 7 twos are 8, 5, 7, 1, 4. Because after this, again 2 will repeat. Are you getting my point? Look here. Once I start with 3. Now 3 where it is here? 30 where did you get? You got the 30. You got 30 here. That means your first number will be what? 7. 4s are 28. What's the remainder? 2 is the remainder. 7 twos are 14. So 0.428571 will be the answer. Right? So are you understanding? Okay, let me tell you last sixth one what it will be. 60. Where is 60? 60 is here. 7 eights are 56. Your number will start from 0.857142. Got the pattern how you are getting it here? Yes. That is what they have asked us to observe and do it. So, we will simply write, after writing this, I will write it here, where you have to write it below. Therefore, by observing the pattern, of the quotient when 1 divided by 7 we get. Similarly, we can predict the quotient of other numbers. Now let us write other numbers. 2 by 7. So 2 by 7 from where we have to start? 14. 7 twos are 14. I have to start. So 0.285714 dash. 3 by 7. Where is 30? 30 is here. 7 fours are 28. 0.428571 bar. Next number 4 by 7. 40. 40 is here. 7 fives are 35. So 0.571428 bar. Next number is 5 by 7, 50. 7 sevens are is 49. 0.714285 bar. Last number I'll write here. 6 by 7 is equal to 60. 7 8s are 56. So it will start from 8. 0.857142. So this is how you actually predict the decimal, right? With only one given pattern. So let's start with the next one. Next one is very important. So from rational numbers or from number system, what you can tell is this is one compulsory question what they will usually ask you. Express the following in the form of P by Q. So I hope you have written down this. Expressing in the form of P by Q, as many sums you do, only then you can practice it. So I have given you homework in this because there are only 3 sums given. I'll solve all 3. There are some worked examples on this where you can practice those worked examples for expressing them in the form of P by Q. Okay. First one, express the following in the form of P by Q. But the first question is third being first one. 0.6 bar. Okay. First you see that we'll solve the first sum and we'll again solve the second sum also, because sometimes you not understand why we have to do like this in the first sum. Once we do 1, 2, 3 sums, you will understand why we have to do and what technique is being used to solve. See, sometimes most of you are in the school, they use let r is equal to or x is equal to, any variable can be chosen. I will choose x. Let x is equal to 0.6 bar. Okay. Now 0.6 bar means actually what? This is nothing but 0.6666. This is the number given. What number it is? Periodically recurring number, right? Not terminating this. Now the main aim in this given sum is to remove decimal and to remove bar. Okay. So now if I just assume that this is a decimal and this is a bar. So bar separately and decimal separately. But here the decimal, if I remove one decimal, it is after that bar only. That means if I have to remove the decimal here, it is only after decimal, only one number is there, that number only has a bar. So to remove this decimal, with what I have to multiply? I have to multiply this with 10. Why 10? 0.6 into 10 if I multiply, the decimal will go away. Multiply by 10. So after decimal also is after 1 and bar is also after 1 number. That is only for our confirmation, clarification we have written. So this is 10x, this is equation 1 because we are only multiplying once here. 10x is equal to 6.6. Why 6.6? It is 6.6 bar, no? Because I multiplied this by 10. So this decimal will go here. This decimal will go here means what number is there after decimal? See here, 6.6666 is there. So it is always after decimal, whatever number is there. But I will not put the bar now because we removed bar as well as we removed decimal. How did we remove it? By multiplying that by 10. Here in this question, we could do both the things simultaneously. You will understand my next question what I mean by this. So this is equation 2. Subtract equation 1 and 2. So 10x minus x is equal to 6.6 minus 0.6. It's bar, keep it as this. 10x minus the x is 9x. 6.6 decimal division, decimal subtraction, be very careful. Always have a working column with the points what you have. 6 and 6 0. So this is 6. So it is 6. X is equal to 6.9. X is equal to 3 by 2. 3 2s are 3 3s are 2 by 3. This is how we represent 0.6 by in the form of 2 by 3. Okay. I'll solve the second one and then I'll actually explain you what I mean by this decimal and what I mean by this bar. Okay. Now look at the next one. Second one, what they have given here is 0.47 bar. The bar is only on 7 but not on 4. Let x is equal to 0.47 bar. Now what did I tell you? Our main aim is to remove decimal and bar. But first we have to remove decimal and second we have to touch the bar. If I have to remove the decimal, that means total decimal means it is 2 places, right? But I can't touch decimal and bar together. Here I had no other option. I had to remove decimal because decimal also was after 1 only. Bar was also after 1 point only. So I could remove them simultaneously. But here it is not like that. There are 2 numbers. So decimal I can only shift after 1 here because next bar is there. I can't be touching that. Multiply by 10. I will not name this equation as 1 because now what will happen? I will have further more multiplication. The last 2 multiplications only we consider them as 1 and 2 equation. Multiply them by 10. 10x is equal to, this is, one decimal will shift here now. 4.7 bar. Okay. Now look at this. If I have to shift the decimal and bar totally, again only 1 point is there. Together I can remove it. Again. Multiply by 10. So 10 into 10, 100x is equal to 47 point, what should come? 7 is recurring, so it is 47.7. Okay. So this is my equation 1 and this is my equation 2. Subtract equation 1 and 2. One thing, be very careful children, because when you write subtract equation 1 from 2 or 2 from 1, it will be like you have to stick to that from. So if you don't want any confusion, just write subtract equation 1 and 2. Your from 2 will nowhere come there. So always bigger minus smaller we prefer here. 100x minus 10x is equal to 47.7 minus 4.7. 100 minus 10, 19x is equal to, let me show you this, how to go about it. 47.7, 4.7. Decimal always should fall under decimal only. 7 minus 7, 0. 7 minus 4, 3, 4, 43. X is equal to 43 by 90. So this is how we represent it. Now I just show you some examples of few more decimals, how to go about this. You have to write this down. And we have the last one. I'll finish that last one and I'll give you some random examples about shifting decimal and bar. Confusion will not be there. Okay, I'll just erase this first one so that third one I can do. One main thing children, what you have to remember here is count decimal is after how many numbers and bar is on how many numbers. That is our main thing to see here. Look at this third one. 0.001 bar. Okay. 0.001 bar. Let x is equal to 0.001 bar. Now see here, decimal and bar are after same numbers here. It is not like that. Decimal different and bar different. That means if I am removing decimal, bar also will go along with it only. Multiply by what? Multiply by 1000. Okay, 3 numbers. 1000x is equal to, so this will be, when we remove this, what will remain? 1.001. Again, repeat that numbers whatever it is. Now here multiplication only one number is there. So this part is only equation 1 and this is equation 2. Here what happened? We had to multiply 2 times. So last 2 we consider as 2 and 1 equation. If we had to multiply 3 times, last 2 again. First one is left as it is. Now subtract equation 1 and 2. 1000x minus x is equal to 1.001 minus 0.001. Let's do the subtraction if you want here. 1.001, 0.001. So 0, 0, 0 and this is 1. 1000 minus 1, 999x is equal to 1. X is equal to 1 upon 999. Now let me give you a few examples about how to shift decimal and bar, but we are not solving those sums, just for your clarification. I am just giving some random examples. Okay. Now let me take the similar type of question here. I will choose the question as now. Okay, let me take this same question only. I consider this as 0.001, but now I put the bar only on one number. Okay, so only on one number my bar is there. First step will be x is equal to 0.001 bar. Now see here, to remove decimal, how many I have to, decimal is separate here, bar is separate, no? So first to remove decimal, how many I have to multiply? 100. X is equal to, what will I get? I get here, decimal will be here, 0.1 bar. Then to remove this bar, again I have to multiply by 10. 100x into 10 is equal to 1.1. So this is 1000x is equal to 1.1, equation 2, equation 1. I am not doing further, just to tell you example. Let me take one more example. Now 0.4732 and the bar is here. So now first of all, to remove decimal, x is equal to, okay. Now decimal I can remove only 2 times, 2 places I can skip, bar later. So to remove decimal I have to multiply by 100. 100x is equal to, so what will happen here? 47.32 bar. To remove 2 more things, I have to remove that bar. 2 more zeros are required. So it is 100 into 100 is equal to 4732 point, what is recurring? Only the recurring you will write here, 0.32. So did you get an example or idea now what actually we are doing in the sum? So this is your equation 2 and this is your equation 1. Okay. So this is how we do it. These are just random numbers I just chose so that you will understand how to deal with this bar and decimal separately. Here I am not giving any homeworks. You have similar worked examples in the textbook. We will solve them for your practice. We will quickly move on to the next one. Express, okay, 0.999 in the form of p by q. Let's see what answer we will get there. They have given something. Are you surprised by your answer? With your teacher and classmates, discuss why this answer makes sense. Nothing, no need of any discussion. It's the answer we get and that's the answer what we get here, 0.99. See, approximately when we talk about what is 0.999, it is 1 we consider, right? That is what we get the answer here. So, I'll erase this. We'll quickly move on to the next one. Very important these sums are. Express 0.999 in in the form of P by Q. So question number 4. Let x is equal to 0.999. So that is x is equal to 0.9 bar. Now you know what to do this here. 1 decimal 1 bar. Multiply by 10. 10x is equal to 9.9 because 9.9 is recurring. So equation 1, equation 2. Subtract equation 1 and 2. 10x minus x is equal to 9.9 minus 0.9. So 9.9 minus 0.9. So 9.0. 10x minus 9x is 9x is equal to 9. X is equal to 9 by 9. X is equal to 1. Okay. So this is the answer. So now quickly we'll move on to the next one. What can be the maximum number of digits in the repeating block of the digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Yes. They have asked us perform a division for this 1 by 17 and check what will be the answer and how many digits will it take. Repeating block of digits. That means this is not terminating, but it is recurring, but it is periodically recurring. To attain that periodically recurring, how many digits it want? Now see here in that previous sum that we did, that is 1 by 7, it took 1, 2, 3, 4, 5, 6. It took 6 digits. After 6th digit, 7th digit was again repeating. I mean 7, 8, 9 what you take, those 6 will repeat again. After 6th digit, the recurring was that means periodic recurring was possible. Now here what they are asking, divide 1 by 17, see what is the length of the quotient which is recurring and where is that periodic place after which it repeats. I will not be dividing that here because it will require 16 numbers. That means when I divide it in the quotient there are 16 digits. After 16th digit it will start recurring. So I will give you answer. What the answer will be here, but you have to divide it. Okay. So my answer, I think you all can find out. So hint is 16 digits are there. After 16th digit only this will start periodically recurring. So this is homework. 5th one. Now we look at 6th one. Most of the questions in this chapters in this exercise are in theoretical. Look at the several examples of rational numbers in the form of P by Q where P and Q are integers with no common factors and other than 1 having terminating decimal representation expansion. Can you guess what property of Q must satisfy? So I think you have not understood anything in this question here, but I'll make it very simple now. Now they are asking here is, suppose if I give you a number, say I tell the number is 1 by 5. Only looking at the denominator, okay, let that be any number. Say the number is 1 by 5, 2 by 5, 3 by 8, 4 by 125, 6 by 50 or looking at this number, okay, only looking at the denominator, that is it is in the form of P by Q. Only looking at Q, can you tell the given numbers are terminating without performing actual division? Difficult, right, to tell, but it is possible. How? There is a property of Q, that is for rational numbers P by Q. Q has a specific property. If that Q satisfies or Q falls under that property, then we can say that the given decimal has a terminating, given number is terminating. Okay, what is that? That is something when a given rational number is in the form Q should always be in the form of 2 raised to n into 5 raised to n, where m and n are what you can say is positive integers, what you can say. But what is this? Why n and m only? N takes some value, m will take some value. Exponents, what I am talking about. So if q is in this form, only then it is, otherwise no. Now 1 by 3 or say it is 10 by 3, whatever it is. Looking at denominator, I will tell that it is not divisible. I mean it is not terminating. Just looking at the remainder. Or assume I have one more number, 5 by 27. Denominator is 27, hence it is not terminating. I can tell easily. Why? Because it is not in the form of 2 raised to n and 5 raised to n. Now what do you mean by this? I will solve the sum. Let me explain this to you first. 3 by 8 let me take. 8 can be written as 2q. Yes, that means I can write this in the form of 2 raised to 3 and 5 raised to 0. What is 5 raised to 0? 1. It is in the form of this. We should have these both. If the denominator is 25, so it is of the form 5 raised to 2 into 2 raised to 0. Correct? 2 raised to 0 we can take, 5 raised to 0 we can take. But in case we have any other number apart from 5 to, say we had some expansion and that number was 3 raised to 1 was there. Because only when you multiply. Now 25 and this 3 also was there in that particular place. Now that means then it will have a non-terminating, that means it is recurring. Now what principle or what things I am teaching you actually to you now is, you have a separate exercise in your standard 10 where we will be dealing with this type of sums, and not only with that, looking at the decimal, looking at the number, you can tell that they are terminating. Also you can tell after how many decimals they will terminate, only by looking at the number. That is also there, which is studied in your 10th standard. So here now what we will do is, we will only list down few 1 or 2 numbers there, and let us understand what property of q will satisfy. We will write that property of q, right? So here they haven't given any example, so we will choose some examples 1 or 2 and give the property of q. So see here what I have written is, consider a rational number p by q where p and q are integers and q not equal to 0. Let q is equal to some set of rational numbers I have written such that whose denominator should be in the form of 2 raised to m into 5 raised to n, where m and n are real integers, I mean whole numbers, what you can say, positive integers. Only then the given numbers are terminating. That means what property of q satisfies? This property of q satisfies. Example, 1 by 2 can be written as 2 raised to 1 and 5 raised to 0. Simple children, this is the technique. You can also divide it and show that it is divisible also. But this is what is important here, how we write. 1 by 4, 2 square into 5 raised to 0. 5 by 8, oh sorry, I need to write here 5. 2 raised to 3 and 5 raised to 0. 36 by 25, 36 by 2 raised to 0, 5 raised to 2. See, it is not that we have to write 5 first or 2 later, anything, and so on. So this is the property, special property of q. If it satisfies in the form of 2 raised to m and 5 raised to n, then the given number is terminating. In 10th, we will also study after how many decimals it is terminating. So we are left with last few questions. Very simple they are. I hope you have copied this down. So let's clear this. So copy the next question where they have asked, write 3 numbers whose decimal expansion are non-terminating. See, such numbers when they ask you, you cannot have a particular answer. It has to be always a different answer. Seventh one, write three numbers whose decimal expansion are non-terminating and non-recurring. Now when they mean here non-recurring, it is non-recurring only, not periodic. Anything can be your example. So I will choose some number. Solution. So first number I will write this as 0.73073 anything 00073. They are not periodic. See, first time it is 1 0, second 0, 3 0. Some pattern I have followed. Dash dash dash. I mean no pattern I have followed. Second number I can give it as 0.768213 dash 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 dash. Anything number comes. No recurring part here. Any number, you can have your own set of numbers. Last is 0.8010986. Some random numbers we have written. These are recurring, irrational, not terminating. Okay. Eighth one. Find three different irrational numbers between the rational number 5/7 and 9/11. See, understand the question. They have asked us irrational numbers between these rational numbers. So we have to find irrational numbers between rational numbers, means the numbers has to be recurring part. So what first we will do here is we will divide 5/7. So 0, 7 sevens are 49, 5/7, right? We have already written here. We have already solved that. So we know what answer, and that has to be what? It is actually non-terminating, but it is periodic. We know that. So we have to stop it at one particular point of time. So let us write down that 49, 1 remainder, 0, 7 ones are 7, 3 remainder, 7 fours are 28. Why? Because these are rational numbers. They have told insert irrational between rational. They are rational, that is why it is periodic recurring. 7 fours are 28, 2 remainder, 0, 7 twos are 14, 6 remainder, 0, 7 eights are 56, 4 remainder, 0, 7 fives are 35, 5 remainder. I can't do that further. So it is, when we divide this 71428 so we will write here 5/7 is equal to 0.714285 bar. Okay, keep this as it is. Now I will divide this number, that is next one, 9, 0.11 8s are 88, 2 remainder. So 11 twos are 22, I cannot take. 11 ones are 11. So remainder is 9 here again. So what I will take? Again 11 eights are 88, 2 remainder. 11 ones are 11. So again 9, which will go on. So 9/11 is nothing but 0.81 bar. Okay. So we got these two numbers as in the form of this. Now our step is to insert irrational numbers between this. I will again draw a line and do it here. Therefore, irrational numbers between 5/7 and 9/11, that is between 0.714285 and 0.81 bar are. How many irrational numbers we have to frame? 3 irrational numbers. Okay. First one, how do you frame the irrational numbers between this? Now, just see here, we can frame anything. 0.71 it is there, right? 0.71 and 0.81. one number. Again children, your answer can differ here. Next, second set of number, what I will write is between these two numbers can be, I will choose one number as 0.7989120005. No, 10 will take, not too many zeros. Something like this. Dash, dash, dash. Okay. Last number, what I will write here is 0.80134 dash dash dash. Okay, because 0.81 we have. So that means these are three different irrational numbers between the rational numbers. Sometimes they can also ask you find three irrational numbers and rational numbers between the rational numbers. So be very careful while looking at the question and reading the question. So the last one, we will finish it today. With that we complete this exercise, as well we will complete today's session. So classify the following numbers as rational or irrational. So first of all, first one is root 23, second one is root 225, third one is 0.3796, fourth one is 7.478478 dash dash dash. Then the next one is 7.478. Fifth one is 1.101 001 0001 1 2 3 4 0. Oh, this 40 has gone. 3 4 zeros 1. Okay, now we have to tell whether these are recurring or not recurring here. So look at the first one. We know that all square root numbers are irrational, but what about 225? Any square root, if it has an answer, those will come under rational, because root 225 is what? 15. So first one is irrational. If you can find the square root of a number, then that will be rational. This is rational. This is turning 18, so it is rational. In bracket, if you want to write, write here. It is turning 18. Okay. Look at this. 478, 478. So this is nothing but 7.478 bar. Okay. Be very careful while observing the number. So what number it is? Do one of this one. So you shouldn't make mistake on just looking at the number. So this is rational because it has periodic recurring. Okay, and the last one, there is no pattern at all, so it is irrational. So now you have a perfect idea about rational, what type of number, and irrational number. With that we complete this exercise. So in today's class I have given you some homework. The first is division. Then also I have given you one more long division where the number repeats after 16 digits, that you have to do it. I have also asked you to practice few things based on how to frame in the form of P by Q. Practice that. And any doubt in today's class you can call on the same day of the video center.